There are three key elements that contribute to an explosion potential. The first element is you have to have the presence of dust. The second element is you have to have an oxygen source present. And then the third element is an ignition source. And if you remove any one of these elements from the triangle, then you've eliminated the potential for an explosion or deflagration. Because you're storing these products in mass in some kind of an enclosed structure, there's going to be dust created in that filling process. And so as the product is dumped into the storage vessel, the product stream will open up as it falls unconfined through the air, and it creates this dust cloud during filling. Over the process of time, the dust concentration builds up and builds up to a high enough level where there is sufficient in the air that you have the energy potential to cause a deflagration or detonation. The dome is built monolithically, little by little, as it can support its own weight, and because it's self-supporting, it doesn't require any internal structure, which means there's no internal surfaces to collect this dust. There are going to be changes in the product that will cause it to give off heat reactions. A little bit of heat generated by each molecule can cause a larger mass to begin to generate a lot of heat. Then that heating reaction may get out of control to a point where it's generated enough heat that the product can combust. And because the dome is a completely sealed membrane, waterproof, airtight, you eliminate this source of moisture ingress through penetrations in the exterior covering. You create this barrier against temperature change to the inside of the dome. The shape of the structure, the dome silo structure, is inherently very strong. Because of this continuous transition from a vertical stem wall into a hemisphere, the dome has no discontinuities. Because of this very strong nature of the dome, they're able to withstand very large internal pressures. The dome structures naturally can take somewhere on the order of 0.6 bars of internal pressure. And so 0.6 bars is in the range of 10 psi. But when you imagine that over tens of thousands of square feet, then you start to realize the magnitude of pressure and force that this dome can withstand without failing. There's a different solution to every different industry. And to this point that we've been in over 500 domes that we've designed and constructed, we feel like the dome is the best solution in the industry for storing combustible products that have a propensity to self-heat, are hygroscopic, or have the possibility of having a deflagration.